What we have here, guys, is which one do you want me to do first? 8. Now, question 8, and yeah. Okay, now we asked for question 8, right? So, question 8, just let any of you guys know when you have a perfect square, and that could be 5 squared, it can be x squared, it can be anything. It can be something as big as this. It can be anything. Once there's something in a pair of brackets and it's multiplied by itself, it's guaranteed to be positive, no matter what is in there, no matter how big or how complicated it is. Is everybody right with that? Now, what you're going to do is, I have a couple of these learned off by heart, okay? The ones I have learned off by heart are stuff like this. I have a plus b squared. I know that when I multiply that out, it's a squared plus 2ab plus b squared. If you're wondering how to prove that to yourself, it's just that, and you multiply it out, and it turns into that. The other one that you're going to need is a minus b squared, which is a minus b by a minus b. Once again, when you multiply that out, it becomes a squared minus 2ab plus b squared. You need them, okay? You have to have them. And you should be able, if I said x plus y squared, it's exactly the same thing, except instead of a there's an x, instead of b there's a y. It's the same system, okay? So what's going to happen here, guys, is I look at question A and I go, okay, multiply both sides out. So I'm going to get is a plus b by a plus b, and that's going to be greater than 4ab. I multiply it out, I get a squared plus 2ab plus b squared greater than 4ab. I move to 4ab to the left. In these questions, you're always going to have a 0 on the right hand side, and there's always going to be something over the left hand side. So what we're going to have is a squared. Now this 2ab, 4ab gets taken away from it, so what does that mean? Minus 2ab plus b squared, yeah? And then that's one of the ones we had earlier. Is it the plus one or the minus one? It's the minus version. And this is always guaranteed to be bigger than 0 for what reason? It's squared. A squared number is always bigger than or equal to 0. Okay, that's how you do one of them. I suppose question 13 would be a good one. Anybody want 10 done, or just 13? 11 followed by 11 followed by 13. Okay, so this is a good trick here. I'm looking. If I just look at the first part, okay. If I do the reference number and that, what do you think will happen there? Just ignore the q squared for a minute. I'm just very interested in this part. It looks very much like a quadratic equation to me. Sorry? Reference is plus 25. So what then? Okay, which will turn into p plus 5 by p plus 5. And then there's a q squared there greater than or equal to 0. And then you get p plus 5 plus q squared greater than or equal to 0. Everybody alright with that? You can say that's a square, it's bigger than 0. Q squared is a square, it's also bigger than 0. So when you add them together, they also have to be bigger than or equal to 0. Number 13 would be a confusing enough one. 13, also what's good about 13 is the fact that there's a lot of multiplying in it. So it's a plus b by a plus b minus 2ab when I multiply that out, plus 2b squared. On the other side we have a 2b squared, and we have a 2ab. Now the 2b squareds will cancel each other. Why? It'd be minus, yeah. Okay, multiply this one out, and we plus another ab, which would be 2ab, yeah, plus b squared, yeah, minus 2ab greater than or equal to 0. Sorry? Oh, sorry, the other 2ab. Oh, okay, that's what I forgot about. So, minus another 2ab greater than or equal to 0. Thank you. I'll cancel that one with that one. And what I'm left with is minus 2ab plus b squared greater than or equal to 0. That's what I'm left with. And then I can just do a minus b squared. A perfect number squared is bigger than or equal to 0. Here's this question 4. You have to prove that it's always bigger than 0. Now the problem is you can't reference number this, can you? And even if you could, would it be a perfect square? No. Now this is worth a lot of marks. What can you do about that? Look at the middle number, and once you look at that middle number, what you do is you open up two brackets. Okay? And then you half that middle number to minus 2 both times. Is that alright, Mark? Okay. Now, what you do next is, guys, you multiply it out, and you get x squared minus 2x minus another 2x. Now, it comes clear why you did this, because minus 2x is minus 4x, okay? So what you have here is x squared minus 4x. It's very similar to what you had a minute ago, and then plus 4. Now, yeah, what Josh said is correct. The problem here is that it's exactly the same, except one of them's a plus 13 and the other one's a plus 4. To correct this, I put in a plus 9 at the end. And then once I've done this, what I do is I get this part here and I change it back into this here. It's the same thing. So I change it back into x minus 2 squared plus 9. Can anybody tell me why is this always bigger than 0? Sorry? Squared and a plus 9. Or technically speaking, you could always think about changing 9 into 3 squared if you wanted. And you say, look, that's also a plus a squared number as well. But that's unnecessary. You have to do this part. I'm going to tell you one other thing about this. Remember that when you're looking for your minimum value or your maximum value, what you always do with the square number, you try and turn that to 0, don't you? I'll show you that question in a minute. Yes.